a good start this year, even though we have the coronavirus going on. So it's still a lot of interesting thing in the telecom industry. We focus on data center, network security, and service providers, and we offer a complete solution for ISPs. So we focus on Juniper, Infinera, and Accedian that we're going to talk about today, and they also have the MEF certification products. I still get some message that there's something wrong with my microphone.
I can hear you clearly, Robert.
And the screen, do you see thing good?
Yes, everything is perfect. Everything is perfect.
Yeah,
for me at least. I hope customers can see. Is more important.
Yeah. Accedian is a part of our infrastructure portfolio. That's about the core network, the metro, the access, and on the CPE side, where we have the different kinds of Accedian CPEs in the top right corner. And Zoltz is going to talk about the monitoring and of the network, and also the MEF carrier Ethernet need portfolio. And in some area we have delivered some MEF solution where we used a Juniper switch with MPLS in the metro or aggregation and so on with the Juniper FTTH switches, and together with a 1 gig solution or the 10 gig solution from Accedian to have a complete MEF certified delivery. So that was all I had to start with, and then I will stop my sharing so Zolt can share his presentation.
Okay, thank you, Robert. Just a minute. I'm sharing my screen. Can you see my screen? Can you see my screen, guys?
Yes, it's perfect.
All right. Okay, cool. Thank you. So welcome everyone. I'm Zsolt Hegedűs. I work at Accedian as solution engineer based in Budapest, and today with Robert we plan to introduce you the latest development in Accedian, focusing mainly the network optimization based on performance metrics and the analytics of these performance metrics. Before this call, I've got to know that you have all knows about some kind of product portfolio of Accedian, but just briefly, Accedian is a Canadian based company, a global company. The major key player in the network and application performance analytics market, and yeah, we started with the Ethernet demarcation and aggregation devices, and then gradually developed performance monitoring capability, and then the virtualized product portfolio. The SFP sensors are introduced, and lately, a couple of years ago, we bought a French company, the application monitoring company named Performance Vision. So we have a complete portfolio from layer 2 to layer 7 to monitor. So today I put together a slide set with this agenda. So I would like to introduce you a couple of business challenges, business services performance challenges, and how we can help to resolve these challenges, and a couple of slides about what is Accedian Skylight, exactly how does it work, and some update slides about the legacy performance elements and the sensors as well, the management architecture, the orchestrator, and the performance analytics. I will show you some customer use case, and the end of this presentation I will show you a demo of the Skylight performance analytics. We have a customer demo system live with this analytics, and I can show you the basic main capabilities of this system. So let's get started. Business service performance challenges. I'm pretty sure that you know these challenges better than me, but yeah, one of the first, the end-to-end performance visibility. It's really can be a challenge, not just the fault monitoring the services, but the performance KPI, the key performance indicator monitoring from end to end, because this the KPIs influence the end user experience, and these KPIs are affected mainly the network performance from the edge to the up to the core. So the bottom line question that how do you get a full end-to-end performance visibility about the services, not just network, not just links in the network, not just the port on the routers, but the services. It's the bottom line question, and also it will enables you to isolate these issues, not just to recognize, hey, we have packet drops or delay, increased delay in the service, but you have to be able to isolate them, and how many users affected by this. So these really are basic questions, and today it's really a challenge to answer. And the third one can be less important, because you can see the micro events, detecting micro events. And okay, but why it's important to see the micro events which can take just 10 or 20 or 50 milliseconds? Because the answer is simple, because it has a tremendous effect to the user experience. So I will show you later on what is the effect of the small burst of packet loss to the user experience, especially in the TCP-based services. And finally, but not least, the SLA service level agreement should be monitored, as you have business enterprise customers. You contracted with them in the services with service level agreement, with service level specification, and you have to be able to monitor these agreements. And and two other challenges: the key application performance. It's a bit higher level monitoring. It's closer to the layer 7, or it's a layer 7 itself. So how do you understand the performance of key hosted application and user experience them, and how do you proactively monitoring these applications to keep the end user satisfied with these hosted applications? And also the hybrid cloud performance visibility, how do you provide complete visibility across of these? So these are the main challenges we think nowadays most of the managed service provider are facing. How can Accedian Skylight help to overcome all these challenges? So in this diagram, it shows the general business service architecture. There's enterprise locations where we can put either Accedian elements, well, you know, the traditional is on a demarcation or service aggregation devices with performance monitoring capability, or we can put there modules, SFP modules, or other modules controlled by Skylight Control. And also we are able to implement our solution in the data center or the public cloud environment or large enterprise location, implementing there or installing them agents or on-prem, cloud on-prem devices to monitor the application level performance. So with our solution, we can enables you to see a complete end-to-end visibility over the whole network infrastructure, and you can see the actual real-time visibility of the performance of the services. And all these elements, all these performance elements, Skylight performance elements, are managed by this Skylight orchestrator, and the orchestrator really just managing the elements, creating sessions, performance session, creating services, and you can initiate a service activation test after creating the service, and the orchestrator collects the measured KPIs and streaming up to the performance analytics hosted in the cloud, in the public or private cloud. And performance analytics can ingest, you can ingest the performance analytics external performance monitoring data. So if you have a Cisco or Juniper devices, it has standard-based monitoring counter. You can ingest these counters to the performance analytics. The only requirement that these KPIs should be a time series data, because performance analytics really developed for analyzing time series data. So these are the key differentiators for business services by Skylight portfolio. We provide unsurpassed performance visibility and data granularity to make you enabled to detect the performance issues on services you're providing to your end customers. So actually, you can see what other solutions miss. I will show you some details about later on. And as I mentioned earlier, we are able to provide a visibility from layer 2, from Ethernet layer to the layer 7, the application layer. And it's also a unique system that you will be able to correlate application level performance degradation with the network issues in one solution, in one system. And yeah, it's fully virtualized. Yeah, I think it's now it is normal that we don't need to hardware server to set up our solution, so we can install our solution in the customer virtualized host machine, a VMware or KVM host, and yeah. Yeah, the scale and the performance, we are able to monitoring the tens of thousands of customer endpoints, with tens of thousands of performance sessions, and the results of these measurements. It's important to analyzing by leveraging the big data and machine learning algorithm in the Skylight analytics to minimize the manual analysis, and it's tremendously speed up the localization of the problems. And final but not least, we have open APIs, the application programmable interfaces, both in the Skylight Orchestrator and the Skylight Analytics, which enables us to install our solution as an integrate part of your IT infrastructure. So we can get commands and instructions via API to Orchestrator. For example, if you create a service from your management system, and this management system has an API interface, over this API interface, this management system can interact with Skylight Orchestrator and instruct the Skylight Orchestrator to initiate, to create the TVAMP or other measurement sessions to these new endpoints. So in this way, we can eliminate the manual configuration of these sessions, but it's true for the analytics as well. So what is Accedian Skylight? In a couple of words, we generate performance data in the most granular and precise and efficient way. So what does it mean in practically the precision? We can provide 1 microsecond precision, and the sampling rate can be scrolled down to 1 millisecond, which really enables you to detect the microburst I mentioned earlier, and we can get down to 1 second of reporting period. So and finally but not least, the efficiency means that the sensors and the modules and elements are able to calculate the metrics over this reporting period. So and what does it mean, this metric? So we create a sample vector for reporting period and sending just the result of this calculation to the analytics. So it means that, for example, if you have 1 millisecond sampling and 1 second reporting period, instead of sending 1,000 measured values, we can, after this calculation, we can just send 10 or 15 calculated results, which practically means that the minimum and maximum values of the KPIs over this reporting period, or average and the percentiles, and it's really an efficient way to measure and generate the KPIs and store as well. Much less storage you needed. So when the collect and store the data in a scalable manner, it means that we are managing the SFP sensors and the modules by using the NFV TVAMP method, which means that the sensor itself the control plane decoupled from the measurement layer. So the SFP sensors really simplify the hardware-assisted measurement probes, and it means that we have multiple Skylight controller, and it can be managed thousands of sensors and modules. And if you have a larger network, multiple Skylight controller can be implemented and managed by one Skylight orchestrator. And all of these data are streamed to, as I mentioned, public cloud via an adapter. And yeah, basically that's it. And analyzing the data and produce insight that can have meaningful impact to your customer business and the customer quality of experience. It means that you can imagine that if you have a large network and you have a couple of 10,000 or thousands of business services, and when you enable the performance monitoring, it will generate a tremendous amount of data. And if you start to analyze this data manually, it's really not an effective or efficient way, because when you finish this analyzing, probably the problem already stopped or solved. Other way, this manual analysis takes a couple of hours or even days. So with the automated machine learning and artificial intelligence algorithms really helps to speed up these calculation and getting insight right away to the actual status of the performance of the services. And I will show you later on the analytics demo the top down and the down to top workflows, how you can quickly in a few steps, in a few clicks, get to these insights and results in the analytics. And it's very important that we are able to customize our analytics to the customer network, which means that we are able to receive metadata of the sessions. So you can put any kind of information about the session, the endpoint router IDs and the endpoint port IDs, the vendor of the router, where the session terminated, or the geo coordinates of the endpoints, and we can visualize these metadata in the analytics, which means that it's really helpful, because we can build up logical topologies or logical heat map, or even logical event map as well. And yeah, we are able to manage all of this in a way that can be fully automated and orchestrated, which means that these orchestrator and analytics can be a part of the larger IT ecosystem of your environment, and we can interconnect our Skylight system to other OSS or BSS system, or the network management system, or even more to SDN, software-defined network controllers. And this enables the performance monitoring-driven traffic steering and routing, because that can be in the future and the near future. So how does it work? The Skylight solution has three layers. As I mentioned earlier, the top layer is in Skylight Performance Analytics. Yeah, the basic function is to provide you network and application analytics and visualization. Yeah, it's absolutely developed in the cloud environment, which means it's able to scale in a huge size, able to analyze billions of data points, and the most important to get a very short time the insight. What are the pain points in the network, and I will show you this capability in the demo later on. And the Skylight orchestrator in the middle part, this element is the centralized management or orchestration of the Skylight sensors. As I mentioned earlier, it's managed, which means that it can collect, or you can configure either manually or automatically the sensors at the deployment phase, and then with this orchestrator you can configure these elements. You can create either services or virtual connectivity endpoints on the services and create sessions and manage sessions, and ultimately orchestrator collecting the performance data from these sensors. And these sensors practically contains the legacy elements, the Skylight performance elements, and the needs actually, and the newer development of nano or SFP compute and modules controlled by the Skylight sensor control. And also we have on-premise and cloud sensors which can be deployed in the cloud infrastructure, and also in agents which can be even implemented or installed into a smartphone, for example, and you can generate TCP throughput test from a smartphone. That's mainly interesting for the mobile network operators. Yeah, and the networks, we are able to monitor any kind of networks. The only requirement is Ethernet-based, but I think it's now a general standard that all the networks are based on Ethernet protocol. So it can be either mobile network or managed service providers or hybrid and cloud providers. Some functions of these elements are presented in this slide. The Skylight performance analytics, as I mentioned, are able to find the micro details, which means that you can zoom into an event where you find some suspicious behavior on the KPI, and I will show you later on the capability of the tool that from on a week window you can zoom into 10 minutes, and you can change the granularity of the presentation on the graph, so you really will get the real value of the KPIs. Thanks for the sampling rate that we are able to sampling these KPIs in 1 millisecond or 10, 100 milliseconds, really up to your requirements. But not just micro data, but macro view can be presented in the analytics, which means by leveraging the metadata, we are able to present a network level overview of the KPIs for a specific time period, even to last 30 days or 60 days. It's really up to you. And yeah, the machine learning, artificial intelligence, it's a key part of the analytics, because these algorithms enables the rapid time to insight. As I mentioned earlier, you don't need to manually analyzing the huge amounts of KPIs. Yeah, the Skylight orchestrator is as I mentioned, the centralized orchestration and management of Skylight sensors, has APIs, open APIs, so we are able to very quickly adapt our orchestrator to your IT environment, interconnect with other elements of your network management ecosystem, and we are able to automate the whole workflow of performance monitoring. And the Skylight sensors, as I mentioned earlier, we have a wide portfolio of elements and modules and software agents and on-premise sensors as well. So this, yeah, I think this part was presented earlier, and let me jump over to the Accedian performance elements part of my presentation. Any questions so far? Okay, if not, let me continue. I prepared this presentation to focusing on the most recent elements, performance elements in our portfolio, and these are the GT, GX, LT or LTS, and the LX, and the common attributes, all these elements, that all of them have FPGA powered MEF carrier Ethernet service creation. You are able to create Ethernet private line or Ethernet virtual private lines on these elements, and create service aggregation functions. And yeah, we have MEF 10.3 based hierarchical QoS bandwidth regulators, and yeah, it's very efficient way of policing the ingress traffic. And yeah, GT has egress shaping as well on the hierarchical way. And yeah, the LX is the latest, the newest part of this portfolio, released just in last month. It has 4 10 gig SFP plus interfaces, and yeah, it's also has the similar or same capability as the others. Yeah, this FPGA allows to have this dual plane FPGA architecture, where we have the packet processing plane, and top of that we have the test and measurement plane, and this allows to create wire speed and high performance packet processing, and we are able to create a service activation test, a performance monitoring test, and in service in a 24/7 way, continuously monitoring the performance sessions. And yeah, what else important? Yeah, the 4 can be interesting, that we're able to install these elements either inline or out of line way. It's really up to your requirement. And yeah, the 0.5 is also important, that we can inject the sessions, the performance session, the performance traffic without service disruption. So practically these traffic load is very low, and a couple of 10 kilobit per second. So nowadays it's really really nothing. And you can define these sessions either on the port level or VLAN level or the class of service level. So it's a wide variety of the monitoring. Yeah, the flexible layer 2 service creation and mapping capability of these devices, so we can have a couple of features to manipulate the VLANs, adding customer VLAN and popping customer and service VLANs, service tags, and we are able to manipulate the class of services really according to your needs. So wide variety of the service creation capability in these devices. I mentioned earlier this Metro Ethernet Forum 10.3 standard, which defines the hierarchical traffic engineering, hierarchical bandwidth policing, and all of these elements are MEF 2.0 compliant, and it's a very efficient way to create service policers and maintain the proper CIR and EIR contracted with the customer. Another application that if you have ring topology of optical infrastructure, you can create 10 gig Ethernet rings with this G.8032 Ethernet ring protection, which allows you to really fast switching in the case of link failure. So it's if you enable the 3.3 millisecond of connectivity checking messages, it allows the elements to switch in 10 milliseconds the services from the failure part of the ring, which is really necessary in the today business services. And we have a proven interoperability. It's important because most of the cases in the one of the ring gateway side can be a third-party equipment, Cisco or Cian already, anything else, and we have a couple of experiences and about this interoperability. So all these four elements are able to put in this Ethernet ring protection. Yeah, I mentioned earlier this service activation testing. It's also standardized based on either RFC 2544. It's pretty old, 20-year-old RFC kind of standard, but there is a much newer and more service-oriented and network-oriented standard. It's a Y.1564. We are supporting both, but I personally recommend this Y.1564 because it is able to monitor simultaneously several class of services. And well, basically after you create the service, the Ethernet service to the customer, before handing over the service to customer, you have to create a service activation test to verify the proper configuration of the service, and testing the CIR and CIR plus CIR, testing the policing, the proper working of the policers by the overshooting by 25% of the CIR plus CIR, and you should expect a packet dropping. And finally, you can measure quick performance test as well the packet drops and delays and delay variation. And after this service activation test, the Skylight orchestrator are able to create a test report in the PDF format, and you can hand it over this test report to your customer, and you can archive in your system as well as a birth certificate of this service. Yeah, and it's important that you can measure this service activation testing nowadays with handheld devices, but in this case you have to send a technician on the endpoint and put the device on the endpoint and start the measurement, and it's really not so-called cost-effective way. And with our solution, you can eliminate these track rollouts. You can dramatically reduce the OPEX and the CAPEX costs. So it's also important to keep in mind. This capability is in service throughput testing. After you hand it over the service to customer for use, and customer start complaining about the perceived CIR. For example, they are not satisfied the throughput of the service. You can verify this this service throughput with our unique solution, and the performance element can monitor continuously the customer traffic on the ingress side, and they can supplement test traffic to this actual customer traffic up to the CIR in real time. So in this way, you can immediately verify the CIR of the service. You don't need to schedule a maintenance window to verify this, and you don't need to interrupt the customer traffic either. Yeah, and I put here the data sheet of this latest performance element. I will send it to you later on to review it. But these are some major feature set of this FSX. This is the I would say it's a purpose-built Accedian performance element, mainly for our business customers, our finance bank or insurance companies, or trading companies, where the accurate time sampling and time stamping, it's very important that because of the regulation. And yeah, I don't know if it's too relevant for service provider, but I put here that we have also such a Skylight element. Yeah, and let's see the Skylight sensors. And the Skylight sensors, there are two main types. One is the FPGA integrated into SFP, or if you don't have an equipment on an endpoint with free SFP slot, we can provide you a module. I will show you later. It's a separate small device you can put in line to the service and have the same capability as the SFP sensor. So the SFP continuous performance monitoring like TVAMP or SOAM. And all these modules are controlled by Skylight Sensor Control, and this control creates and configure the sessions and send it down to the SFP compute, and SFP compute can initiate this session and starting the measurement, and all the results are sending back to Skylight Control, which forwarded these results to orchestrator and up to the analytics. Yeah, the two major continuous active performance monitoring is presented here. The TVAMP, the two-way active measurement protocol, RFC 5357, which operates on layer 3. But we also have layer 2 standard implemented in our sensors, the Y.1731. And yeah, it's important to mention that we have huge experience with fully interoperable with third-party responders, either radio base station or switchers or routers. So these standards, the TVAMP and Y1731, are widely implemented in the network vendor devices, and we are able to initiate sessions towards these third-party responders. So, for example, you need to put our SFP into your P router, and you can initiate these sessions to the CP or radio base stations. If in the case of mobile network level or VLAN level, P-bit level. And with these standards, we're able to monitor plus 50 metrics, which is really, really important. And yeah, and the key differentiator that our sensors with the FPGA, the hardware-assisted measurement, we're able to provide this microsecond accuracy of the measurement. And we are able to measure the one-way KPIs, so we can measure separately the downlink and the uplink performance indicators. Can be also important in nowadays, because this asymmetric network load in the network is quite general, and the load on the routers are pretty asymmetrical. Yeah, and then as I mentioned, the sampling can be down to 1 millisecond, and yeah, basically that's it. This continuous active performance monitoring. Yeah, these are the modules I mentioned earlier. Yeah, it's pretty same like any other SFP. As I mentioned, we have already developed the 10 gig SFP plus. SFPs just recently became general availability in our portfolio. We also have 1 gig SFP, either optical or copper, and in the case if you don't have SFP slot in your CP, you can put our modules in the endpoint, and you can put in the daisy chain with this with your CP with our Skylight sensor. And yeah, both module has a 1 gig or 10 gig capability or version, and we are able to install these modules into outside. It's really relevant for the small cell application in the mobile network architecture. And one important feature I haven't discussed yet, the capability of monitoring the bandwidth utilization in the down to 1 millisecond sampling rate, which will really helps you to find the microburst. Where is the microburst in your service? How long that microburst, and when did it happen? Because otherwise, if you are not able to detect the microburst, you will see only the side effect of the microburst, that the latency will be longer, the end user response time will be longer, because the TCP retransmission will be more and more, and the end user will immediately realize that something wrong in the network. And when he starts complaining, without this microburst detection, you will not see anything. So it's really important that you can localize in time and in space where is the microburst happened. And I mean the space that where in the service path this microburst happened. I will show you later on this localization in the analytics demo. And yeah, and this feature, the distributed packet capture, it's also a unique feature. I guess that we have a flow broker function implemented all these SFP compute, which if you realize, for example, if you realize the utilization start growing and it's reached the certain level, you are able to automatically enables the packet capturing, and the device starts capturing packet by packet, and it's able to stream up to the sensor control and the Skylight orchestrator in the PCAP format. And then you are able to later on analyze either in Wireshark or with our PVX product, which actually the analytic performance monitoring solution of Accedian. So it's an interesting use case. So it really gives you a tool that you can dive into a detail, and you can analyze and find which traffic, which application will causing this higher utilization in your service. Yeah, NFV-PM, it's really a unique solution and unique feature of the Skylight solution, that NFV means the network function virtualization, which actually we divided our performance elements, and the control plane was implemented in the Skylight sensor control, and the data plane remains in the modules. And this way the modules are simplified device, and all the intelligence are hosted in the Skylight sensor control, which means this control manage the sessions and the collecting of the sessions. But in the centralized testing, it's pretty obvious that you can create sessions from the central position to the endpoint, and you can measure the services from your core to the network edge. But with this NFVT ones, you are able to create a side-to-side testing. So if you have a service which has a full mesh topology, you are able to create sessions between the endpoints and the remote endpoints via this assured TCP tunnels, the Skylight controls, and the measurement session configuration to the remote device, and the remote device initiate a session to other remote device. So it kinds of proxy port, and here is the test origin. Here is the test origin, and this is the endpoint of the test. And this way, you are able to monitor any traffic topology in your network. Yeah, dual plane architecture. I already mentioned this, and yeah, this is the basic idea of this NFV performance monitoring. Yeah, this important to mention that it's able to measure the layer 3 and the layer 2 services in this way. And yeah, this slide is interesting that the title, it's meaningful that you can't control what you can't see. So what you can see, this is a perception. What you can see, this is a kind of round trip delay of one of your service, and you can see, well, okay, it's pretty fine, but what is the reality? And I have an issue that impacting uplink and downlinks independently, separately. So actually, this is the perception, and this is the reality. If you can measure separately the uplink and downlink, then you will get closer to reality. That you can see that here is the uplink latency measures, and this is the downlink measurement. And as I mentioned earlier, it's a requirement nowadays that you should know exactly what is the KPIs separately on the uplink and the downlink, and we are able to monitor it, not just the delay, but any other metrics, the packet loss or delay variations, and loss burst, for example, the continuous packet loss in time. We are able to detect these important KPIs independently to uplink and downlink. And why I mentioned a couple of times the sampling rate importance. Why it's important? The importance of the sampling rate, because the higher the sampling rate, you will get the more accurate and more realistic data about, for example, the utilization of a link. So, for example, if you have just 1 second sampling rate, you will see an average 23 megabit per second in the same period. And if you change the 10 times higher the sampling rate in 100 milliseconds, then you will see the maximum of the average utilization will be 179 megabit per second. And if you go down to 1 millisecond, you will get 980 megabit per second. So these are the real value, and if you're comparing to 1 second sampling rate, it's more than 40 times higher the value. So it's important. know. And if you're just thinking about the current capability of the network devices, these devices in the SNMP counter, you can set, I don't know, 15 seconds for the sampling rate, and you will really see just a high-level average of the utilization, not the real level of the utilization. So it's important, and this sampling rate also reveals the microburst I mentioned earlier. Yeah, with this separation of the control and the data plane and the measurement plane, you can significantly reduce the total cost of ownership. You don't need to deploy large servers. You can install all of the management component of the Skylight into virtualized environment. You can install our devices with zero-touch provisioning, which means you don't need to pre-staging in the lab each and every sensors. You can send a technician with the sensors on the end side and just plug in to the device, and that's it. And the device will be automatically discovered and configured into the Skylight orchestrator and Skylight sensor. Or you can leverage our IP agnostic mode of operation, which means we don't need a separate IP range for managing our sensors. For managing the sensors, we can leverage the IP address of the port behind the sensor, and we can communicate over this IP address with the special unique TCP port to the sensors, which also helps you to simplify the managing the devices and administrating the devices, because you don't need separate IP address range for these devices. Yeah, and the security aspect, it's also important that you don't have any local console port on the SFP sensors, no open interfaces to hack, and we have a secure TCP link between the Skylight control, the Skylight sensor control, and the modules. Okay, let's talk about a couple of words, the Skylight orchestrator, which is a central part of our solution. As you can see in this diagram, the orchestrator able to manage every kind of Skylight sensors, either modules or elements on-prem or cloud. Yeah, mentioned earlier, the automated unit management, the zero-touch provisioning, it's basic functions of Skylight orchestrator. You are able to create jobs easily, and you have to just create one job on one time with the specified parameters for the service creation or session creation, and then you can either duplicate these jobs to other elements, or you can run these jobs to a bunch of sensors. So it's really an efficient way of managing and configuration all these elements. You don't need to manually configure one by one each of the sensors. So it's really simplified both the provisioning and both the operation of the element. You have visibility for the alarms generated by the sensors, and as I mentioned earlier, Skylight orchestrator are able to create this service activation test based on these standards. And yeah, the basic functionality is the performance data collection from the endpoints, from the modules, sensors, and streaming these data up to the analytics. Yeah, the device discovery I mentioned already, and yeah, fully virtualized. We are supporting both VMware and KVM environment, and automation, yeah, with open APIs. I mentioned earlier this example that you can automatically setting up sessions for the new services, and indicated over this API by your management system. Yeah, this is about the metrics collection, and granularity and scale. Yeah, I think 200,000 objects sessions are more than enough in the nowadays in the even in larger network, and yeah, it's integrated with Skylight Analytics, either CSV or XML format. The orchestrator sending up these format the KPIs to the analytics. Yeah, and with the Skylight orchestrator, we support the full coverage of the service life cycle. So from not just from activating the services, but also creating the services and service activation testing, and then after you handed over the service to the customer, you are able to monitor continuously the performance and behavior of the service, and if it's needed, you can modify the service based on these performance indicators. So if you realize that the customer often overload the CIR, you can offer them a new code with a higher CIR, for example. So it's also interesting. And I mentioned that all of these monitoring are based on standards DVAMP and Y1731. All of these standards, measurement and metrics. So yeah, performance analytics. This is the top on these whole portfolio and whole solution. It's purely cloud-based, either public or private cloud, and yeah, we can ingest. I will show you later on a couple of hundred of KPIs to the analytics. So it's really scalable solution. Thanks for this cloud environment and technologies. And basic features to visualize these KPIs in the effective manner, combining with metadata and analyzing, and with analyzing the KPIs, and with the metadata you will get instantly a clear view which service are affected by the performance degradation and where. I will show you later on in the demo about this very important feature. Yeah, in a large network, the volumes of KPI means the billions of data points per day. So it's really high scale. In, let's say, in the network in US or Russia, in the countrywide network, you can easily reach these number of data points. But yeah, the analytics can cope with these size of data as well. Yeah, I mentioned earlier this artificial intelligence and machine learning algorithms. It's really, really important to get to know instantly what is the situation in the network level or into a service level as well. And the closed loop automation, it's interesting use case. I will show you later on in the use cases how to automate the service optimization with analytics. And yeah, this is the architecture of the performance analytics. These are the sensors in the network streaming the data, performance data to orchestrator, and orchestrator send this to a roadrunner. Actually, these elements, the roadrunner, Skylight orchestrator, are implemented and installed in the customer environment, and all these performance analytics components are in the cloud. And the analytics are able to communicate via API to OSS, BSS system. So, for example, you can ingest, let's say, Cisco telemetry data, performance data to our analytics and correlate with the performance metrics measured by our sensors. It can be another use case. So when you realize, hey, there is a packet loss or delay increasing in the service, you can correlate this event with the Cisco telemetry data, and you can narrow down which router can be suspicious then, and you can monitoring the CPU of that specific router, and correlating the CPU or memory utilization of router with the KPI measured by our independent sensors. It's really a powerful tool to localize the problem in your network. As I mentioned earlier, the public cloud or private cloud, it's both implementation are supported. Yeah, it listed some examples of the metadata. You can when you create a session, a performance session, you can add network-based data, metadata to each and every session, and you can assign the region which region this session is working, which technology, which network equipment vendor is working behind this session. What is the customer name? What is the service type? And you can even add geo coordinates, and you can visualize in analytics in the geo map the result of this session. So it's a really, really important feature, the analytics, that you will not see only a measurement, you know, in just monitoring in the network level a couple of thousands of graphs, and just seeing the name of the session, and this is not an efficient way. Then you need to another network management system to further develop or further troubleshooting. Okay, I realize a problem on that session with that name, and okay, take another tool and start searching for that session name and start troubleshooting on the other system. Instead of this, we are able to add as many technical data, metadata to the session, and we are able to correlate this data and visualize this data. I will show you later on. Yeah, the streaming agent, the Skylight, Roadrunner, and these are the formats that we're supporting. I think it's not so important slide, but yeah, these are the more important. The customer use cases. I will show you later on this in the demo system as well, that the macro monitoring, the top-down workflow that you have, dashboards you created earlier for the network level, for example, delay and the packet loss, and it's just one simple card, and you can create a threshold profile with any meaningful threshold in milliseconds or percentage value with the packet loss, and you can assign the critical, major, minor threshold crossing event, and you can be able to visualize these events in this pie chart in this time range, for example, past day, but you can see in the past hour or the past 30 days or 60 days. So it's really powerful, and you can see these KPIs in the graph as well. And if you click on this, either the major or the minor side of this pie chart, you can see the top contributors of this major delay. And here are the monitored object, the sessions itself. Here is the values, and you can really 3 simple steps. You can select the sessions. You can drill down to see what the impact of the network issues are, and you can correlate the Accedian data with the external data, as I mentioned earlier, for example, the Cisco telemetry data. So you get instantly an insight. And the third step, you will see the top contributors, and you can analyze only that one session with this logical event map. Well, the analytics show you the end-to-end topology of the service, and all the components on the path will be shown with a small pie chart for this threshold profile with this metric, and you can select the direction, and the size and the color of the dashboard represents how many and which kind of threshold crossing event happened. And yeah, it's really powerful. This is what I meant earlier, that you can localize the problem in the time, so you can change the time window over here, and also the space. I mean, in the route of the service path, you can easily identify which are the top contributor of the problem. Yeah, and the geo heat map, you can see all these KPIs on the geo map as well. Yeah, this is not a use case how to correlate the throughput and the delay in 3 steps. I don't know if you can see it. It's a pretty small letters. I'm sorry for that, but this is a 1 month period of the throughput utilization, and you can create custom metrics and the packet size or packet per seconds as well. calculated from the received byte and the received packet. And you can see here the throughput average and throughput max. And here are the exact values of the minimum, average, and maximum values over this 1 month period. You can see it's a 25 meg is the max. And I select this day and zoom in quickly and see and correlate the delay and the delay max and delay percentile 95 with the throughput of that link, the throughput average and throughput max. And you realized as the throughput is growing, then the delay started to grow, both the max and the P95 started to grow. And here's the power of the metadata. You can see separately the service classes. So this is the 4G services mobile network operator, but it doesn't matter. You can see the purple color represents the EF class, and the green is representing the best effort class, and you can represent the measurement separately for these two service classes. And you can see here the values, and you can further zoom into that period. Now we are just in 10 minutes a period of time, and we changed the granularity to 1 second. And it's important to see that now you can see the real value of the delay. It's getting higher, the 13 milliseconds, and it's the same for both best effort and EF class, which is obviously not normal. So it's just 3 steps, 3 simple steps to get into the insight of this of the performance behavior of the service. Yeah, and this is the closed loop automation I mentioned earlier. It's can be a typical use case for the future network or the near future network in the SDN world, the software-defined networking, which is really about how to automate the network. And we can provide performance metrics for create a proper decision by the SDN controller. So the analytics can send performance events up to the SDN controller, and based on that events, SDN control can modify the network below that. So here this is representing the network itself, and we are monitoring the network, collecting the data, creating events, and sending these events up to the SDN controller. And based on this event, SDN controller are able to create or make decisions and create modifications on the network and on the services. And this is near real time modification adjustment on the network. Yeah, this is a real use case of this workflow in the MEF 2018 showcase. We got an MEF award for this. This is our partner is Colt, and Colt has a service in London, and we have the Skylight sensors implemented in the endpoint of this service over Colt network. We are collecting performance data with the Skylight sensor and orchestrator, sending this data up to performance analytics, and analytics sending these performance events up to the Colt controller, and in an online way automatically, and the Colt controller, based on these performance events can make decisions to modify the services or adjust the various attributes of the service, either CIR or CBS or EIR or any MEF attributes can be modified automatically. So it's really in line with this life cycle service orchestration MEF LSO initiative. Yeah, this is one dashboard for this use case. I haven't talked about much details about the metrics, but I will show you later on in the demo, analytics demo, that we are able to monitor and measure the service availability. So the sensors and the elements are able to calculate in the device itself the availability of the service itself based on the measured KPIs, either performance or a packet loss or the delay. And this measured availability became a percentage, and it's also a time series data, and we are able to present it as a graph in the Skylight Analytics. And ultimately, this is the bottom line metrics, I guess, because it's a composite metric, and most of the time service provider contracted with customer, and this is one of the major parameter in the contract, the availability, service availability measured in, let's say, 1 month or 2 months or half year or 1 week. It's really depends on the parties of the contract. And also traffic utilization, it's important, and we are able to represent these data side by side, and regions by regions, and by services. Yeah, these are the two workflows I mentioned earlier in the Skylight Analytics, the top-down and the bottom-up workflow. Yeah, I will show you later on in the demo. Yeah, I think yeah, I can show you later on this demo. So let's jump into the demo, and just a minute. Can you see my demo screen?
Yes, it's looks great.
Okay, great. Yeah, so this is a monitoring dashboard of our Skylight Performance Analytics. These are the one demo dashboard created for, well, it's a pretty general for either mobile network operators or managed service operator, managed service provider. You can see the macro view here, that the packet loss in the network level comparing with the threshold you created. You can see what is the percentage of the OK, which is below a specific threshold. Let's say it's a 95% of packet loss. over this 1 day period. And the granularity is 5 minutes of this measurement. You can put here any other KPIs, the jitter max, the delay, and you can represent these KPIs on the map. It's we call it a heat map, and you can zoom in and you can define where are these problems occurred in your network. So these positions are highlighted with different colors, which means the different threshold crossing events. Yeah, as mentioned, that red is critical, and yellow is warning, and green is okay. And the size of these circles means the numbers of the events, threshold crossing events on this location. And so these geo heat map, it's really focusing on the services, not the network. So it represents the KPIs of the services. And I can scroll down, and you can get some more details about these KPIs. With the metadata, you were able to split up these KPIs by regions and regions. So you can see how much is the packet loss on the west region, north, northeast, central, east region. And also the jitter and the delay. And you can also see the time series data per region and region. And you can see the top component of the high packet loss. So this is the top contributors of the packet loss by target city. The target city is the type of metadata, but you can put here any other metadata, and you can group the KPIs the way you want. It's really flexible. So it's just one example, and it's also applied to the other KPIs: jitter max, delay, and throughput. And if you wish, you can change the time window to past 7 days, for example. And all of the pie charts and graphs are updated automatically. And for example, let's say in your, just a minute, let's wait a bit. And there is some delay. Yeah, let's say, for example, in this 7 days, you realize that, hey, let's say we have SLA contracted with the customers, generally for 5 milliseconds of delay, and you realize that over the 7 days there is one region, the north region, which has 10.3 milliseconds maximum. Okay, and let's drill down and analyze this event a bit closer. So you can zoom into this event and select a lower time window. Maybe I was too fast. Let's zoom out. Yeah, start again. So just zoom into this, and yeah, you can change the granularity immediately from 10 days to 1 day, and down to 5-minute granularity, you can see that the north region in the 1 day time with 5-minute granularity, you can see the maximum delay is 14.7 milliseconds. I'm just presenting, demoing the delay, but you can apply this methodology for any kind of metrics. Okay, and let's zoom in more to this problematic period of time. Okay, you can, let's wait until loading all of the data, because it's a bit slower because all of the component of this dashboard, all the cards are updated automatically as I zooming into the time. And let's change the granularity from 5 minutes down to 1 minute. Yes, let's wait a bit. Still loading. So now you can see just we are in the 4 hours. And here is the north region. Okay, and let's focus on this peak only. Yes, let's wait a bit while all the data is loading to all the cards. And okay, let's change both the interval from 4 hours to 5 minutes and granularity from 1 minute to 1 second, 60 times higher. And you see 18.6 milliseconds was the value of the maximum delay on that region. And see, but the real value is 71.6 milliseconds. So this is the value what I mentioned in the presentation, that if you have high enough sampling rate for the measurement sessions, you are able to see the real values of the KPIs, not the average. So in this case, you are able to see the 1 second granularity, the real value. So over these 5 minutes, you realize there is a problem in the north region, because both the average is 12 milliseconds, but there are peaks with 71 milliseconds. Okay, and who are the contributors? You can ask. Hey, here are the contributors of this high delay. Oops, there is 196 milliseconds, one monitored object, and you can either select the top 5 or top 10. But let's say just focusing the top 5, which is over 20 milliseconds, and you can select this top 5, and you can start monitoring for these top 5 components. And this is a composite monitoring where you can see not just the network behavior and network KPIs, but also above these networks, the application monitoring. So it's a server response time and the query response time, and what is the top source IP, and yeah, you can drill down the errors, database errors, or yeah, it's a delay what we looking for. You can, let me select, it's a bit slow, I'm sorry for that. It's a demo system, maybe it's needed some time to loading. But anyway, you can see not just the graphs, but also the distribution of the values of delays over the period of time. I'm sorry. Typical demo behavior. Let me reload the page. Yeah, so let me go back to default combo dashboard, for example. This is the dashboard of combination of layer 3 and layer 7 KPIs. You can see the delay on one direction, the probe to reflector direction, and the packet loss and the jitter for this period of time. And in this dashboard, we put there some layer 7 application based KPI. So if you have such a network behavior, you want to know how is that affecting the customer experience in one specific application. And you can see here the KPIs collected our PVX system, which is application monitoring system, application performance monitoring system, and you can see the average page load time in that application level, the client round trip time, and ultimately the end user response time can be the ultimate goal to measure the bottom line, that how much time the customer has to wait for the response of the application, and all those things can be correlated easily and quickly with the network KPIs. And also you can select the top sites, a top application, and so on. And the last features I would like to show you, the bottom to top. It was a top to bottom workflow, and the bottom to top workflow. If your network or service operation center has a trouble ticket from a known service with a service ID, and the service ID is added to the session name, they can quickly filter or search for that service ID and select, and they can see the metadata of this service ID. So in this demo system, we created this type of metadata, as you can see, and we can visualize the service path based on this metadata here. And what's more, we can go down and start showing a logical event map on this specific service. And here we created a threshold profiles. Let's select the default threshold, select the metric of this threshold, let's say the delay P95, and select the direction, let's say P2R, which in our case means the downlink direction. And what is these thresholds? You can click on this sign and you can see the delay P95, the SLA is 25 milliseconds, minus 45, 100, 150 is the critical, which 150 milliseconds, it's really high. And yeah, you can see immediately in the past day what was the average violation counter on the endpoint, one endpoint, and the components. You can see here all healthy in the past day on these components. So the customer complaining, your operator able to focusing on this long path only these two components, the endpoint, the prediction CP, and the router in the 0042 router. So they don't need to troubleshooting each and every component, just these two ones. You can also change to other direction. Yeah, the uplink seems okay. Everything is fine. So you are able to see which direction and which components are affected and which way. So here you can see the size of the pie chart, and the color of the pie chart indicates the number of the threshold crossing events. So yep, and finally I would like to show you the data ingestion capability of the analytics. At the moment we are able to present 365 metrics, and we have just selected 57 metrics, and here are the types of the metrics. You know, the Accedian types of metrics, but most of them, of course, are standard based, like TWAMP or SOAM, delay measuring, or packet loss, or all of them are standard based. And here you can see the third-party metrics. You can ingest KPI metrics from third-party devices, Sienna, Cisco telemetry I mentioned earlier. You can put CPU and memory utilization into analytics and correlate with the measured KPIs by our sensors, and some others. Yeah. So basically that's it. Any questions or comments or feedbacks?
Yes, Solz, thank you. I think
You're welcome.
I think we will share the presentations, and
yeah, sure.
hope everybody had a good overview of what we can offer with the Accedian solution. And thank you for
You're welcome.
joining the webinar.
It's my pleasure. Yeah, and if you have any question, feel free to either contact Robert or me. Yeah, we are really open to get to know your use cases. We have a couple of hundreds of use cases from other customers, but of course, some of them are common with general with others. But yeah, if you have any use case, any problems, feel free to contact with us, and we can start talking about that and finding a solution for that use case, for that problem.
Yes, then I say thank you for now.
Thank you very much.
Thank you. Bye-bye.